Hello everybody. Today we are going to learn about sampling techniques that are required for ray tracing, and related to that we are going to learn about Monte Carlo rendering. How can we use Monte Carlo integration, which is a numerical method of computing integrals for computing the rendering equation. Okay, so let's write sampling and Monte Carlo. Okay, so because it's based on randomness and there are casinos in Monte Carlo which are also, you kind of need to be lucky, it's also based on randomness. This is what these techniques are called. Now let's remember the rendering equation. Okay, so let's remember the rendering equation, which is the radiance that is being sent out from the point X along WO is equal to the emitted radiance from this point, okay, from X along WO, plus an integral. Okay, so let me try to squeeze it here. It's a hemispherical integral. Incoming radius to X from Wi are BRDF X Wi WO, okay, and our cos theta I, and finally our integration variable, the solid angle, differential solid angle, DWI. Now this is an integral, and as we have learned in calculus in earlier lectures in our life, integrals can be calculated in different ways, right? They can become computed analytically. For example, you can compute the integral of a function, a cosine or sine, using analytic methods. But computing the rendering equation, the integral in the rendering equation, this one, through analytical methods is really impossible. You can only compute it for very well-defined scenes, such as, let's say, you are inside a perfectly illuminating, perfectly reflecting sphere. You know the radiance, the reflectance is constant, and so on. And under these conditions, you may be able to analytically evaluate it. But in this case, in ray tracing, for the general case, this must be numerically evaluated. Okay, and Monte Carlo is a numerical technique.